We want to compute the following integral I. Now, using the Pythagorean identity cosine square x equals 1 minus sine square x, we see that the integrand is a function of sine multiplied by the derivative of sine, which suggests the substitution u equals sine x. Now, using this substitution, our integral I becomes, and this gives I equals the integral of u over 2u to the power 4 minus 2u squared plus 1 du. Now, one approach to deal with this integral is to follow the guidelines for integrals of rational functions. So we have to compute the partial fractions decomposition of this rational function after, of course, having factored the denominator. Instead of doing so, let's first try to simplify this integral, as in the denominator I'm seeing a function of u squared, and up to the factor 2 I'm seeing the derivative of u squared. So this suggests the substitution v equals u squared. Now, it's worth mentioning that instead of these two substitutions, we could have considered from the beginning the substitution u equals sine squared x if we see the integrand as a function of sine squared, which is sine to the power 4 plus cosine to the power 4 times up to the factor 2 the derivative of sine squared, so sine x times cosine x. In either case, we will get the integral of this rational function of v. Now, since the denominator is already an irreducible quadratic function because its discriminant is strictly negative, this is already the partial fraction decomposition of our rational function. In this case, we know that we have first to write this quadratic function in its standard form. But let's first start factoring with 2 just to avoid square roots. Hence, we get, therefore, by using the standard form of this quadratic function, we get I equals 1/4 the integral of 1 over v minus 1/2 squared plus 1/4 dv. Now we recognize here an integral of the form the integral of 1 over t squared plus 1 dt, of course after a convenient substitution. Now, in order to have something like this, we start with factoring the denominator here by 1/4. So after simplifying by 1/4, we will get I equals the integral of 1 over 4 times v minus 1/2 squared plus 1 dv. Then we express this term as a square, and this gives us I equals the integral of 1 over 2v minus 1 squared plus 1 dv, which finally suggests the substitution t equals 2v minus 1. Now, using the substitution t equals 2v minus 1, our integral I becomes 1/2 the integral of 1 over t squared plus 1 dt. So I equals 1/2 tan inverse of t plus c. Finally, we remember expressing our answer in terms of the variable x, taking into account all the substitution we used. And therefore, the general antiderivative of the function sine x cosine x over sine to the power 4x plus cosine to the power 4x is 1/2 tan inverse of 2 sine square x minus 1 plus a constant c.